Hello, on to chapter 2. This is a very good chapter. Um, I'm willing to predict you won't have a lot of fun reading it. It's important to understand how science is done, and particularly the science of psychology. Mark Breedlove and I must think alike because he uses the same example opening vignette here that I sort of do, but he doesn't tell the story the way I do. So let me tell the story the way I do. So there was a German orchestra, and they needed a new oboist, but a major donor to the orchestra had a son who was an oboist and wanted to try out. So to be fair, the orchestra decided that candidates should be shielded, their identity should be shielded as their playing was assessed. So they came out behind a screen, sat down, played their oboes, and I believe the conductor of the orchestra had the decision power. So one person plays, somebody else plays, and then someone plays, and the conductor of the orchestra basically jumps up and said, "Ach du lieber, that's the best playing I've ever heard in my life. The auditions are over. Everybody can go home except that person. We are hiring that person." And out from behind the screen came a woman. And that was not supposed to happen because everyone knew, air quotes with my fingers around knew, that women did not have the chops to play an oboe. An oboe requires a great deal of breath control. And yet, the conductor said, everybody can go home. And they did hire the woman, but they did not give her first chair in the oboe section. And she didn't think that was right or fair. And she sued. And the course went, the lawsuit went as it should have, and they found that it was inappropriate, that it was discrimination, that they didn't give her first chair because blindly they had decided she was the best oboist in the world. And after that, this story here became true. It became the norm that orchestras did their assessments blind. And a miracle happened, and the data are presented in this chapter. And then all of a sudden, women who everybody knew, air quotes, were not competitive at the highest levels of music, suddenly they're everywhere. So knowing what you're evaluating can allow your biases to rear their ugly heads. And it's like all science, and certainly psychological science, has to do whatever is necessary to eliminate this bias. And at the end of this story is something more relevant to non-oboe players. Males are thought to be more competent, and they get higher salaries, and they get hired more so. This is bad, and we have to deal with it, not just in psychology, but in society in general. And there are data on orchestras. And what is a science? Not just psychology, but science in general. Um, so we move in stages. We are slow. We don't jump to conclusions. And we look at variables. And we make hypotheses. And by the way, I usually say an hypothesis rather than a hypothesis. And the hypotheses about variables, and then we have often experiments, but not always experiments, because sometimes we can't do experiments. We do correlational research. And we test our hypotheses, and there's a figure you will have to understand later in this chapter. And a collection of hypotheses together can be put together to form a theory, which is a much higher as much higher level than a simple hypothesis. And what do? Well, as we saw in chapter 1, all people watch the world, and we observe things, and we gossip about things, we talk about things, and science describes things. And there's ways to collect data, there's naturalistic observation, and there's a mall, a very nice mall. We used to send our students to the Steamtown Mall, but they were not good at blending in. They got spotted, and they were politely asked to leave. And there's a discussion of Jane Goodall, and she's impressive, and she's still around. Case studies. Non-scientists love these. I'm a little politically active, and it just kills me that people cherry pick. What's cherry picking? Well, it's picking cherries. You go to a cherry tree, you don't start picking leaves and branches, you start picking cherries. And you don't just pick cherries, you pick cherries that look good to you. And, particularly after the last election, people are cherry picking stories. And, they'll have one observation, one true story, and then they'll post that and say, see, my side is really right and your side is stupid. And it's not that case studies shouldn't be used in science. It's that they're a starting point. They're not an end point. It's not where you run to Facebook and make a post so you can irritate the other side. And there are surveys and there's clipboard, and that's how our people got spotted, by the way, because they were recording data on clipboards. But of course, that person knows they're responding to a survey, and that certainly can bias how you respond to the survey, and that has to be guarded against. And how you word your questions. Oh boy, it's companies that run surveys for politicians. They know exactly how to manipulate the wording of the question to basically elicit, virtually in a Pavlovian sense, the response they want. It's very difficult to have a survey that isn't biased. And yet, if you want to do good science, you have to do it. And then we've got variables. And how much do they covary or move together? And one measure of this is a correlation coefficient. And it's a numerical representation of how things covary. In figure 2.2, I would say that correlation is, well, I don't know, I can't see it all because of the overline. It's not very, very strong. But one thing I absolutely want you to know is that correlations can vary between 1, and by 1 I mean +1, and -1. You can't go above or or outside that range. You have to stay within the range, +1 to -1. And if you're at either end of that range, you have perfect knowledge. It doesn't get any better. There's nothing wrong with a negative correlation. It just means as one variable gets bigger, the other one gets smaller. If you want to know nothing, you want a zero correlation. And we've got some figures here. And there's correlation of 0 in A. And B, you're up to a +0.3. And C, you're up to a -0.7. Now that -0.7 is better than the +0.3 because it's closer to the edge of the range. Another way of putting it is that it's further away from 0. And then on the bottom right is a perfect positive correlation. Note if you drew a straight line through those dots, all the dots would be on the line. And of course, a perfect negative correlation would just be a line that goes down from left to right instead of up from left to right. I do a lot of research using correlations, a lot. But one thing to know, which even science writers who report in which should be reputable publications, they violate this quote down here: correlation does not prove causation. It certainly does not prove. If there is causation, there's going to be a correlation, but having a correlation doesn't prove it. There was a big study that the federal government did looking at the correlation between pornography and I forget what, child sexual abuse or something. And, they found a correlation, but causation, I think not. If there was causation between viewing pornography and committing, sexually illegal acts, everyone on that commission should have been put on a watch list because they spent years looking at pornography. There's a correlation, but it does not prove causation. And, there are correlations. These are examples of correlations that don't prove anything. That one on the left, man, that must be, it's right there, -0.99. And the one on the right is positive 0.6. By the way, the one on the right is used all the time to teach about correlations. That as temperature goes up, ice cream sales go up and drownings go up. When I was a kid, I was taught you had to wait like 2 hours after eating before you went in the water because you would cramp up and sink like a stone. No, it's just a correlation. So the bottom figure here is a good one. X can cause Y, and of course then there'd be a correlation. But Z could cause X and Z could cause Y, which would cause a correlation that did not prove correlation between X and Y. The confounding variable caused the correlation, not the apparent correlation. There was a correlation, but the apparent causal relationship. There's a curvilinear relationship, and you try and draw a straight line through that. It's with a normal 2-point straight line. It's not going to work, and your correlation will be low. And we have or in this case 0, and we have statistical methods for dealing with that. There is discussion of linear and sampling is very important. And the book discusses several issues related to sample and that correlation at the bottom. I've gotten data like that all the time, which is why given what I study, I often separate males and females in my data sets if you look at that, the correlation is quite good, positive 0.6. But if you looked only at men and only at women, the correlations would be a lot lower. In fact, the female correlation looks like 0. The male correlation may be, positive 0.2 or something. So sometimes, usually reducing your sample size reduces your correlation, but it also can get rid of a variable that can cause an apparent correlation that is not real. And there's more discussions about correlation and happiness and hypothesis. Occam's razor. When choosing between competing hypothesis, the simpler one is the one we go for. And I love this comic strip. I read it every day. And there's sexual tension between the males and females, as comes out in that little cartoon. Clever Hans. The horse that could do math and do a lot of other things. And the German government got very interested in this horse. How is it answering these questions? Well, the good news is they hired a psychologist to go in and test this. And the owner was not trying to trick anyone. But when you ask it, the only way the horse can answer is by clomping its hoof. So what's 4 plus 2? And the horse would start clomping its foot, and normally it would stop at 6. But it turns out that if the person who was testing the horse, usually the owner, didn't know the question, the horse didn't know the answer. And there's a Law and Order. There are people who use Ouija boards to do facilitated communication in autistic children. And this autistic child was being offered to give testimony in a trial, and they did something very clever. They had something amazing happen to the child, like a clown went running through with a goat or something, but the person who facilitated communication was not there. And of course, the child, if they could remember anything like who the murderer was, they would know the answer. They would be able to tell the facilitator what just happened. And they brought in the facilitator and said, well, what just happened? And amazingly, just like in Clever Hans the horse, suddenly the kid didn't know anything and he didn't get to testify. Amazingly, on campus, we were teaching this stuff. And does it bother me? Yes, it bothers me. Experimentation. The key word here is manipulation. You must manipulate the variable. If you put males in one group and females in another, that's not manipulating. That's selective sampling. I choose males, I choose females. I can't make a male. I can't make you 20. I can just choose you because you're 20. That's not an experiment. Drug trials are common examples of experiments where we manipulate whether you get the drug. And of course, we should do it in a way where everyone is blind to what's going on, so expectations can't play a role. And there are independent variables and dependent variables. And independent variables are the ones you manipulate. And dependent variables are the ones you look for effects of manipulations on. So the drug would be the independent variable. And this chapter talks about depression. Depression would be the dependent variable. This book, this is a really good chapter. So in drug groups, medical conditions, we often, in medical research, we often talk about control groups and experimental groups. And we do that in regular research as well. It's very important that people not know what group they're in. It's very important that people not know when they assess people what group they're in. Otherwise, you've blown it. You have another variable affecting things, and there's the discussion of sexism again. The very same resumes or applications, Jennifer or John makes a difference. And another thing that kills me on Facebook, where people are cherry picking to support their idiosyncratic political beliefs, there's no concern with replication. And replication simply means do it again. Do it again. If you can't do it again, it doesn't replicate. If you can't replicate, you really shouldn't be talking about it. And meta-analysis is very important. And that is worlds beyond what the average Facebook user can understand. A meta-analysis is a big analysis, and that's the term meta. And it looks at data from multiple pieces of research and assesses whether or not there's a real effect that extends across multiple studies. Self-esteem is something that people were very into a while ago. And the state of California put together a commission to study self-esteem. And every chapter in the report started off with correlation doesn't prove causation, which is absolutely true. But they did this because they believed that self-esteem was important, and they couldn't even find correlations. If there is a causal relationship between two variables, there's certainly going to be a correlation. And this was just blind faith. And also, there was industry, there was a learning system where the first thing they had in local ads for like a decade was first they help your kid with their self-esteem and then they can learn. Well, the research indicates that if the students can learn, that improves their self-esteem causally. So there's some gender bias. Strong inference is the process of disproving as many hypotheses as you possibly can. And there's a system for doing it. And most people do not come up with adequate tests that challenge their hypotheses. And this book talks about experimentation all the time. Sometimes you just can't do experimentation. For example, smoking and health in humans. We can't make people smoke. And if you choose people who smoke, that's not a manipulation. That's a participant variable. So sometimes we have to do correlational research, and that requires much more sophisticated thinking than experiments, I believe. And there's some clever Hans again. And there's scientific process for strong inference. I would know that figure. And multiple, lots of data together, lots of hypotheses together, form a theory. Theories usually cannot be disproved by a single piece of additional data. They can be weakened, but they can't be disproved. That name at the bottom of the page, Kuhn, he's a philosopher of science. He's quoted a lot in courses on the scientific method and building a theory on hypothesis testing. I would know that too. And theories that can't be disproven fall outside science. And I love it that he's talking about, somewhere he talks about Freud in relation to this. he was great at generating theories that could not be disproved. And here we're talking about the matrix. Um, and people do talk about whether we're living in a simulation. Man, if you can't test it, leave the building in terms of science. And there's Freudian. He's Freud. I'm so happy was a physician, not a psychologist. Uh, we cover him in this course, but I sort of hate doing it. Random sampling. This is hard to do. It's hard to understand what random even means if you don't do this for a living. But populations and samples are relevant. You are a sample of students currently taking classes in summer one. So the summer one students with the population, you are a sample, but are you a random sample? I think not. Who decided that you're taking this class? You did. So you are not random. You are probably not representative. But if you want to do good science, you need representative samples of populations. And there's a discussion of samples, and I have trouble looking at Washington D.C. without thinking about storming the Capitol. People can't recognize random numbers very accurately, as the book points out. And populations and samples, very important. Measures of central tendency. You have to learn these. Politicians sometimes maliciously misuse these measures all the time. In high school, you probably learned, in grade school, you probably learned to calculate the mean. Sum of the scores divided by n. And we've come to use that as what we mean by average, but there are other averages. And I'm not in love with the example A because I would have used Bill Gates for example A, and there in B, you take Bill Gates's income, and if you calculate the mean, sum of the scores divided by n, they'll tell you that the average American makes like $6 million a year. We do not. We do not make $6 million a year, but that is the average sum of the scores divided by n. Now, if you calculated the median, which is a much more appropriate measure when you have someone like Bill Gates in your sample, the median income is the middle score. And so Bill Gates still counts as a score, but his $12 billion income goes away, and the median moves to the middle of the pack. Worry about politicians who talk about averages, not medians. How much you have to pay in the hospital, unemployment compensation, lots of measurements that are politically relevant are parts of skewed distributions. And the mean is really not the appropriate measure of median. The mode is the most common score. If you have Bill Gates in your sample, I would go for mode. I mean, if you're trying to talk about the typical American, calculating the mean is stupid. And you're either doing it because you don't understand statistics very well, or you're a politician trying to confuse people. Outliers, medians, mean, median, mode, frequency distribution. There's a small sample, a medium sample, and a very large sample. And know your axes, y and x. Y is up, x is over. And there's a symmetrical distribution where mean, median, and mode are all the same. So no argument with using the mean there. But there is a negatively skewed distribution next. How do you know that it's negative? Because the tail points negatively. So the tail of the distribution points negatively. It affects the mean a lot, the median a bit, and the mode not at all. And then you have the positively skewed distribution. The tail points to the high end, to the right, mean the most, median less. That's actually more affected in both cases than it really should be. Well, no, that's not Bill Gates. There's a bunch of people up there. And so you have to understand skew distributions, direction of skew, and how the direction of skew affects the three measures of central tendency. And we love statistics. You know who's really good with statistics? Economists. Oh, geez, are those people good? And inferential statistics. To address this question, scientists rely on inferential statistics, mathematical procedures to help infer what the population is like based on a sample. And somewhere here we'll come up with the p-value of 0.05. I think it's on the next page. And measures of variability is important. The simplest one is the range. Highest score minus the lowest score. But that only looks at two numbers. Variance is more common, and we most commonly express variance as standard deviation. And inferential statistics takes this into account. And the next page shows you why. So if you had a sample like in A, you get a mean, and it is symmetrical, so you can calculate the mean there. But you don't trust it that much. If you did that again, that mean would vary. But look at the second one. Again, the mean is appropriate, but boy, that's tight. And if you replicated that sample, it would not move as much. So there's important terms on the right. P is the p-value is the probability that the difference between two samples could occur by chance. Significant a p-value chosen by convention. That is, why do we do it? It's like Fiddler on the Roof, tradition. And we use 5 in 100, which is 1 in 20, and p is less than 0.05. I usually say equal to or less than 0.05, but I'll go with this. Reliability is, can you do it again? And validity is, are you measuring what you intend to measure? If I told you how smart you were, it could be defined by how much you weigh. I can measure your weight very reliably, but is that a valid assessment of your intelligence? I've given you a small link here to show that I've thought about this before. A colleague who's now retired, and I wrote this little paper. It still gets cited occasionally. What is the probability that the null hypothesis testing is meaningless? We were sort of calling into question the kind of hypothesis testing the book is talking about, and that's still being done a lot in the field of psychology. That questioning is being done a lot. And psychological tests. People love to attack IQ. I can give you a reference to a book there's decades of science on IQ testing. It certainly isn't perfect, but it's moderately pretty good reliability and pretty okay validity. Maybe I'll add that link. Unreliable tests can't be valid. And I've already, no, I didn't mention that. If you get a different number every time, validity demands reliability, but reliability does not guarantee validity, as I've already mentioned. And here we are with biases and Coke, Pepsi, and Mark has a little box on the next page, I think, yes. And this is when we were both at UCLA. When the Coke Pepsi challenge, well, no, he was there earlier, but we did overlap. This is when the Coke Pepsi challenge was important. And this is a nice discussion. Former president of the university was a Pepsi human, and suddenly all the Coke machines went away, and people were very unhappy. But the science to this is interesting, and what you think you're drinking can affect your perception. And this is, of course, relevant also potentially to placebo effects, which this chapter discusses. And there's the gold standard, man. Randomized, double-blind, placebo-controlled studies. We had somebody just shooting out random thoughts about what would cure COVID. Randomized, double-blind, placebo-controlled studies be damned. If you don't do that, and you're messing with people's lives, you're going to kill people. You're going to kill people. So there's discussion of this and why it's important to do it appropriately. I have sinned a little bit. I have known the conditions of my animals on occasion. I hope it did not affect my results. Never forget the oboe player. There's stages of research, ethical conduct. Vaccination is in the news now. I'm vaccinated. I hope you are. And there's a discussion of the Tuskegee syphilis studies, where African Americans sometimes don't trust our medical research, in part because of this study, where we let people suffer with syphilis without treating them. Unbelievably unethical. Man. Of course, some people believe we shouldn't teach this stuff because it puts America in a negative light. I started the Institutional Animal Care and Use Committee. I chaired it for a long time. Lots of paperwork. It's important. So human and animal research on campus are both well regulated, I'd like to believe. And there's, meta-analysis and antidepressants. I remember when this was new, and I knew people taking antidepressants, and this was not a great outcome for the antidepressants that they tested. Placebo can be quite real. And there's the end of the chapter. But speaking of placebo, historically, I'm a pain researcher, and believing that you're getting an intervention that helps with pain can really alleviate or reduce pain. So even if you have nothing going for your medical profession, you can hear my air quotes again, but you convince people that, oh yeah, this is going to help, no problem. We're going to help you. We're going to fix you right up. Believing in that is going to help some people. Um, I believe doing it knowing that you've got nothing to offer people is pretty clearly unethical. But people do it. There are whole fields that are probably nothing but placebo. And psychological therapies are often not evaluated well, and that facilitated communication with autistic children is rarely systematically evaluated. So that's the end of chapter 2. It's a very, very important chapter. And there's the overview of Muse on this chapter. Humans are very prone to biases, and sometimes it can lead to really, really evil outcomes. We have to protect ourselves from that. Whoops. Wrong button. See you next time.